Okay, this is the last part of the review for Unit 9A. We're not writing standard to vertex form this time. We're leaving it in the standard form, and we're using negative b over 2a. Negative b, oops, not negative 2b, negative b over 2a. And then after that, we will plug x in to find y. Plug x in to find y. That's pretty sloppy, but you'll get it. All right, so my a value here, the coefficient attached to the x squared, that's a 2. The b value here, the coefficient attached to the x, is a negative 16. And the c value, which we're not going to use here, but it's 35. So if we're going to go negative b over 2a, make sure you're using parentheses. All right, so when we're plugging those numbers in, the b value goes in the top parenthesis. It's a negative 16. And the a value goes in the denominator, which is a 2. So if you've got negative times negative 16, that's positive 16. Your denominator, 2 times 2, which is 4, and 16 divided by 4 is 4. So my vertex has an x value of 4. So we're going to take that, 4, and we're going to plug it into our original equation to figure out our y value. So y equals, I'm going to rewrite the original equation, but instead of x's, I'm going to use parentheses. X plus 35. Okay, and so I'm plugging my x value of 4 into those parentheses. And I'm going to use my calculator here. Please use your calculator. Plug it in exactly like you see it. 2 times 4 squared minus 16 times 4 plus 35. All right, so that gives us a 3. My y value there is a 3. Y equals 3. So my vertex is 4, 3. So we can plot that coordinate. Positive 4, positive 3. Okay, so my h in this case is going to be a negative 4, and my k value is going to be a positive 3. Remember, the vertex is always opposite of the h. Axis of symmetry is always x equals, and it's always the x value of the vertex, so x equals 4. All right, now to plot the rest of the coordinates, again, we're going to have to go back to our original parent function coordinates. Negative 2, negative 1, 0, positive 1, positive 2, 4, 1, 0, 1, 4. And we multiply our a value times all of the original y values. So my a value here we determined was a 2. So we're going to multiply all these y values times 2, every one of them. So 4 times 2 turns into 8. 1 times 2 is 2. 0 times 2. 1 times 2. 4 times 2. So these are the new coordinates I'm using. So from my vertex, I'm going to go left 2, up 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. All right, I'm also going to go from my vertex left 1, up 2. Left 1, up 2. And then 0, 0, that is the vertex. We ignore that one. We're going to go right 1 and up 2. Right 1, up 2. And then we're going to go right 2, and we're going to go up 8. So from the vertex, right 2, up 8 should land on the same line as the previous coordinate. They are mirror images of each other. And our axis of symmetry, if we were going to cut that guy in half, would go right through that positive 4 on the x-axis. X equals 4. All right, and number 5. Oops. All right, so again, identify the a, the b, and the c. A is negative 3. B is negative 6. C is a 1. In this case, we're not going to use the c, but it's not bad to identify it anyways. So we've got negative b over 2 times a. This is going to find us the x value of the vertex. So my b, which goes in the top parenthesis, is a negative 6. And my a value in the denominator is a negative 3. So negative times negative 6 is positive 6. 2 times negative 3 is negative 6. And 6 divided by negative 6, negative 1. So the x value of my vertex is negative 1, which also tells me the axis of symmetry is going to be x equals negative 1. All right, now we need to find the y value of the vertex. So to do that, we're going to rewrite the original equation, but we're not going to use x's. We are going to use parentheses. So -3, we have an x squared minus 6 times x plus 1. Instead of using x's in our original equation, we are going to use the x value we came up with, which was -1. Okay, and this is going to give us our y value, y equals. So, back to my calculator, plug it in exactly like you see it. -3 times -1 squared minus 6 times -1 plus 1. That looks right. So our y value is a 4. Y equals 4. That's the y value of my vertex. That 4 is also my k value. And remember, the h is always the opposite. So the h is going to be a positive 1 right there. So my vertex is -1, 4. -1, -1, positive 4. And then to figure out the rest of the coordinates, we need that original parent function table. 4, 1, 0, 1, 4. And again, we multiply our y values times our a value. Here our a value is -3. So we multiply all the y values by -3. Going to give us our new y values. 4 times -3 turns into a -12. 1 times -3 is -3. 0 times -3 is still 0. 1 times -3 is -3. 4 times -3 is -12. So from our vertex, we're going to go left 2, down 12. Left 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. From the vertex, we're also going to go left 1 and down 3. Left 1, 1, 2, down 3. 0, 0, that is the vertex, ignore it. We're going to go right 1, since it's positive, and down 3. Right 1, 1, 2, 3. And we're going to go right 2 from the vertex and down 12. Right 2, down 12, should end up on the same line as the previous coordinate. Mirror image. And that's all we got. Axis of symmetry, x equals -1. If I was going to cut that parabola directly in half, it goes right through the -1 on the x-axis.